um, that we're keeping all this logarithm stuff straight. So, remember how when we had exponentials, when we had exponentials, the normal one looked like this, but we could modify that by changing the base or changing the exponent or something like that. Well, the same thing is true of our logarithms. So your basic logarithm would be something like y equals 3 log base 4x. That is just your basic numeric logarithm. What does that curve look like? Air drop for me. What does that look like? No one's ever right. We have an asymptote at x equals 0. And then the curve looks like this, right? So increasing and concave down. So that means increasing, but at a decreasing rate, right? Now, we can change that. What happens if we put a negative out in front? So what if we did negative 3 log base 4 of x? What does putting a negative out in front do? Does what it always does. It turns it upside down. So we still have the asymptote, but now it's coming down like this. Everybody agree? Now notice okay, this is a decreasing function, right? Would you agree with that? Decreasing, but it's concave up, which means it's decreasing, but at an increasing rate. Okay? And then we talked about yesterday, what happens if we put, so we have 3 on base 1/2. What happens when we make our base less than 1? It's the same as this. And if we were to put a negative in front of that with a base less than 1, what would that look like? That one right there, right? Okay. All right. That's just a little recap. Now, let's get back to our notes. We're on 211, and we're ready for example 2. In 211, we're ready for example 2. So this is easy. They've drawn a couple pictures for you, and they said, okay, would you consider A to be concave up or down? Up. Would you consider it to be an increasing or a decreasing function? Decreasing. Now, it doesn't talk about the rate of change. It just says simply, is it increasing or decreasing? And that means, is it going up or down? That's all that means. Don't overread it. All right, what about B? Concave down and increasing?
Yes.
Remember, it's not rate of change we're talking about. We're talking about, is it going up or down? Is it an increasing or decreasing function? So B is increasing, it's going up, but it is definitely concave down. Okay, now what about C? We just talked about this. Before I erase it, this is a different equation, but isn't this the shape of C? So it is definitely concave up, and it is definitely decreasing. Now, example 3 is a bunch of these charts again. Be careful. They tell you in the instructions, these are all logarithmic. So what did we learn yesterday about logarithmic? The x's do what? Multiply. And the y's add. So take a minute and see if you can figure out the missing values, the k values, with the understanding these are logarithmic. So see if you can figure out what your k values are going to be. going with Quinn here. He's got them figured out, so I'll let him answer the first one. What do you think Kenny is in the first one? He said 4. Did you say 4? I hope you said 4, because what are the x's doing? They are timesing by 2. Remember, in a logarithmic function, the x's multiply. So, perfect. All right. How about the second one? Who can we pick on here? Oh, okay, Xander.
I got a 2.
You got 2 because remember, the x's multiply, and it looks like they are being multiplied by 3. So to go backwards, he divided by 3 and got 2. Would you agree? Everybody good? Okay. What about the next one? Anybody have an idea about the next one? Definitely Tris. Patrick? He said 11. Tell us how you did that, Patrick. That's what I think it is too. I'd love to hear your explanation. What did you do?
I looked at the x values and saw that it was like +1, +2, +4. Right. It was +1, +2, and then I don't know. I kind of just did like.
Okay, no, so you're kind of doing the right thing. So we're used to, kids, we've done this lots and lots and lots. You're used to looking at the differences. So I know that these are all supposed to be multiplied by something, but clearly there's been something else in there besides the multiplication. So the difference here is 1, this is 2, I don't know what this is and this is, but if I stick with this multiplication idea, this should be 4, and this should be 8. Would that make sense to you? Remembering that these are being multiplied now. So if that's the case, then this would have to be 11, and this would be 19. I think that's beautiful. I think that's very logical. And what about the last one with all the e's in there? Anybody figure that one out? Kennedy? E to the 4th. Because what are we multiplying by? Well, we're multiplying by e cubed. So when we multiply by e cubed, we add that exponent on, and that would be e to the 4th. Very good. Everybody okay? Perfect. All right, let's look at these domain and range things. Again, I want you to go back always to your basic logarithmic function. This equation has no adjustments to it. I mean, it's been times by 2, but that doesn't change the direction or anything in the picture. So, what's our domain? 0 to infinity, and that is open because there's an asymptote at 0. What's the range? Negative infinity to infinity. Exactly. Want to remind you that your exponential, what's the domain of the exponential? Negative infinity to infinity. What's the range of the exponential? 0 to infinity. Because what's the relationship between the logarithm and the exponential? Inverses. Inverses. So this domain and range will be this range and domain. Okay, how about this one now? You did 2 important adjustments. This one takes my picture and turns it upside down. Now, will that, in and of itself, change the domain and range? No. However, what does that do? Moves me to the right 3. So that means my picture, this picture, is moving right 3. So instead of the asymptote being at 0, it's now going to be at x equals 3. Going to have the same shape. Oh, actually, I'm not. I'm going to have the upside down shape. So what's my domain now? 3 to infinity. And what's my range? Still everything, right? All right, tell me what you think about this one. 8 log 2x plus 3. What do you think your domain's gonna be? Perfect. Because what's that gonna do? Shift us 3 halves to the left. And what's my range gonna be? Yeah, negative infinity. Oh, logarithms are so fun. All right, let's look at the lumberjack page, and I'm just gonna focus on question number 4. The graphs of 3 basic parent logarithm functions are shown below. What do all of them have in common? They all have the same range and domain. They all have the same asymptote. They all contain what point? 1, 0. Okay. The equations for the 3 graphs are these. Which is which, and how do you know? Take a second and think about that. We got top, middle, and bottom graph. You gotta figure out which one is ln, which one is log, and which one is base 4. So take a second and figure that out. Okay, what do you think? Have you been able to identify which is which? Anybody have a thought on that? Xander, you usually good for some kind of thought. Do you have a thought?
I'll pass it.
All right, so pass it to
I'll
Kyle.
pass it
All
to
right,
Wes.
Kyle will try it.
I said the solid line was the y equals log x.
So the top one,
Yeah.
okay,
And then the straight, like the straight dashes, the bottom line was the y equals ln x. The middle line was the log 4x.
okay. So Kyle's stab at this, and kudos to him because he's the only one that made a stab. He thinks the top one is log, the middle one is base 4, and the bottom one is ln, right? That's what you said? Yeah. So let's talk about that. Let's talk about that for a second. When we have ln x, base 4, and log, what are the corresponding, what would be the exponentials associated with these? This one is y equals e to the x, so these are inverses, right? This one is y equals 4 to the x, and this one would be y equals 10 to the x. Would everybody agree with that? Okay, so there's a couple different ways we can think about this. When I look at these exponentials, I know what their general shape is, but which one is rising the fastest? So they're all gonna go through the point 0, 1. So let me say this guy right here is y equals e to the x. Now what's e? 2.7, right? So if I now on that same grid step 4 to the x, what's that gonna look like?
It's gonna go up faster.
Isn't 4 to the x gonna go up faster? So it's gonna actually look like this. Would you agree with me? And then what about 10 to the x? It's gonna go up even faster? Now, does that make sense to everybody? So now I want you to think about folding these across the identity, because the logarithms are going to be the inverses of those, right? So see this pink line that's shooting up really, really fast? What is he going to be doing when I fold him? Isn't he going to be coming out like this? So won't log be on the bottom of my pile? And then the middle one is going to be the 4, and the top one is going to be the 8. Let that digest. Does that logic make sense to you? I know it should be different for me because I'm an ancient math teacher, but I do not think well in logarithms. It helps me to translate them into exponentials because that just makes more sense to me. If you're confused by the logarithms, you can always change them to exponentials. Just remember, they're inverses of each other. Okay. So another way to think about it is, since 10 to the x rises fastest, the inverse is going to rise slowest. So your log is going to be down here. Okay. Use the graph. We know our middle graph, I don't have it right here, but we know our middle graph is the base 4 logarithm. Use that graph to estimate log base 4 of 6. Okay, so log base 4 of 6. What does that look like? What is log base 4 of 6? 1.3 or so. Would you agree with that? I mean, we're approximating. Does that make sense? So what does that mean? Interpret that. Log base 4 of 6 equals 1.3. What does that mean? 4 to the 1.3 is 6. Well, let's see how close we came. What is 4 to the 1.3? Ooh, my, good job. We came real close, didn't we? Suppose we shift, number 5, suppose we shift the function y equals log base 4 of x to the right 3 units. So we're going to take our function and we're going to move it right 3 units. What's that equation going to look like? Log base 4 of x minus 3. So there's the new equation. How will this transformation affect the x-intercept, y-intercept, or no, x-intercept, asymptote, domain, and range? Well, we kind of already talked about this. What's it going to do to the asymptote? Move it to the right 3. So your new asymptote will be x equals 3. It used to be x equals 0. Your original y-intercept, x-intercept, your original x-intercept is 1, 0. So what's your new x-intercept going to be? 4, 0. Your original domain was 0 to infinity. What's your new one? 3 to infinity. And your original range was negative infinity to infinity. So what's your new range? Same thing, because when you mess with the x, you're only impacting the horizontal. So anything vertical isn't gonna be changed. All right, back side. Check your understanding. Work on this with your teammate. Notice we're graphing without a calculator. Pay attention to the equation. Then do the matching exercise in number 2, and we'll talk about number 3 together. So do 1 and 2.
Yeah. Okay, yeah. 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 And then I guess it was technically divided by negative 1.
No, but it's right. picture drawing?
Because like here, you know, it's like the base times y equals x. Because it's a logarithm function. That means that whatever this number is, to the
This is
power right here, it has to equal 11. But because there's the x plus 5, the equation would be base times y equals x minus 5. So it's do 11 minus 5, so then you're going to be adding the 5 over. So then it would be 6.
All right, Quinn's up here lounging, that must mean we had enough time to figure it out. So tell me about your picture. What did you come up with when you graphed that? Don't do this to me. Makes me cranky. Talk to me.
Give up the decreasing rate.
So let me look at the picture. Okay, so Quinn's got a picture that looks, he doesn't have any points plotted or anything, but he's got that general shape. And Xander agrees? Okay, well, I'm gonna disagree. Okay? Here's what I want to do. I want to stop and think a minute about what this looks like. Y equals log base 3 of x. Because this is one of our very basic. There's nothing fancy about this. I know exactly what this looks like. Now, since they gave me a grid, I'm gonna plot some points. And me being me, I'm gonna rewrite this in its logarithmic form. And I'm gonna plot some points. So I'm gonna let y be -2, -1, 0, 1, and 2. And if that's y, then my x's are 1/9, 1/3, 1, 3, and 9. Would you agree with that? So I'm just real quick gonna plot those. So 1/9, 1/9, -2, 1/3, -1, 0, 3, 1, and 9, 2. Does this, now this is not what I was asked to sketch, but does that make sense in terms of just my basic logarithm?
Yeah.
Okay. Now, what you were asked to graph changes the sign on x. What does changing the sign on x do to a curve? Reflects it across the y-axis. So the picture that you should have drawn was this, but with negative x values. So it ended up looking like this. Does that make sense to you? The rules that you know about reflections and translations and all that apply to everything, even logarithms. Okay, we good on that? All right, let's look at this matching set here. So graph A, B, C, D, and E, here are the equations. So did anybody find the equation that matched any of these? Xander?
Yeah, so for the first one, it was y equals -2 log 2x. I got a d as a dinosaur.
So this, he says, was D. Now let's see if he's right. Look at picture D. Picture D looks like a regular logarithm upside down, and that's exactly what happens in that. Perfect, Xander. Anybody find another match? Julia?
For the second one, y equals 3 log 2x, I said c.
You said C for this one. Again, does that make sense? Because picture C is a regular old logarithm, right side up. 2 for 2, who's gonna make it 3 for 3, Kyle?
For the third one, y equals 1/2 log 2x minus 5, I said a.
And you think it's A as an apple because
It moved to the right
it
five.
moved to the right 5. Perfect. That's the only picture that moved to the right 5. It's asymptote moved. Perfect. Okay, 3 for 3. Let's make it 4 for 4. Here we go.
The fourth one I had B.
B as in boy. Because,
Because it's moved up 5.
first of all, it's upside down. And it's lifted up. So that leaves, I guess, B for the last one. It's right side up and lowered. Everybody good? All right, we're gonna do number 3 together. And I wasn't sure when I looked at this problem, what the directions, in terms of calculator usage were. So it says write an equation. So we're gonna do one with no calculator, and then we'll do one with a calculator. Because we could certainly come up with a logarithm equation both ways. All right, so let's see what they told us. Write an equation for a logarithmic function that has a vertical asymptote at 5. Okay, so what does that tell me about my equation right off the bat? Kennedy?
It'd be X minus 5.
Yeah, so whatever it is, y equals log base something, this is gonna be x minus 5. Agreed? And then it also contains the point 11,1, which means that if x is 11, then y has to be 1. Which means that b must be 6. So one example of an equation would be right there. You don't need a calculator, that's super simple, beautiful. All right, now, what if, actually, that's so easy, I don't think I need another, I don't think we need to talk anymore, I think that's fine. That's easy, super easy. So we won't even mess with it. All right, on to 212. 211 is due on Thursday. We're gonna do some of 212 here real quick. Look in the boxes up at the top. These are your basic properties of logarithms. We've been using them, because you learned them all last year. But here they are summarized, and he's offered an example of each. Basically, when you take the logarithm of a product, you add the logs. When you take the logarithm of a quotient, you divide the logs. And when you take the logarithm of something to a power, the power becomes the coefficient. Okay. So, example 1. Condense into a single logarithm. So for number A, or for letter A, what's going to be in those parentheses? Kids, we're not dropping the logarithms. We're condensing the 2 into 1. So we still have a logarithm, but now what's going to go in here?
Log 4 XY.
XY. That's it. X times Y, because they were added. What about B? Log base 3 of what?
5 over Z.
5 over Z. Perfect. C. Log base 10 of what? Would it help you? What?
X over 5Z.
X over 5Z. Let's just stop right there. Take a look at that. What do you guys think?
No.
No? What's wrong with it?
Because you have to do x minus 5, divide that by z. So x divided by y, divide by z.
Okay, So let's talk about that, Kyle, because you're right, you're exactly right. But, so is she. Because if you take x divided by 5, and then divide that by z, that's what you're saying is happening, and that is what's happening. That would be x divided by 5, divided by z, which is x divided by 5 times 1 over z. These are both being divided. So you're both right in your processing. Kennedy, this is exactly right. And Kyle, you were right. Think about it like this. But that is the same thing as she had. Does that make sense to you? Perfect. All right, do D, E, and F on your own. We'll compare answers.
This doesn't have 3 in front of it, so by putting this here, does that mean that things can't? So I don't know if you can move the exponent in there, like you have to put this here.
Let's see. Luke?
Yep.
What do you think about the first one here? What do you think about it? What did you put in your parentheses? Now, I don't know what Drew put in his parentheses. What did you put in your parentheses? You don't know. All right, let's talk about that because we need to know. So let's review our properties again. When you see that number out in front, that coefficient, that 3, out in front of a logarithm, that 3 is actually an exponent. Okay? So I have x cubed. So we have 3, or no, we don't have 3 anymore. We have log base 2 x cubed. And then minus the log of y. So look at your properties again. When logs are minus each other, the numbers are divided. So in here, we're gonna have x cubed divided by y. Okay, you got your properties right there, right? You see them?
Yeah.
So we're using those. Okay?
Yep.
Okay. All right, anybody think you got E handled? There's a lot going on in E. What'd you come up with? Emily?
I got log base 7 and then 4a squared over b5.
All right, let's look at that and see what you think. She has 4a to the second over b to the 5th. Everybody okay with that, Raina? You good with that? She's right. She's right. And what about F? What in the world did you do with F? Well, there's a plus there, so I really want to multiply something, but the 2 isn't a logarithm. I turn the two into a logarithm. There's log base 6 of 6 squared. We talked about this yesterday or Sunday. That's 2. So isn't this the same as 2? This is 2. So log base 6 of 36, 6 squared, is 2. So I'm gonna rethink that 2 as the log base 6 of 36 plus the log base 6 of x. Now, that plus sign tells me I'm going to multiply, so this is just 36x. No power. Sometimes we gotta be tricky. All right, one more. Example 2, which of the following is equivalent to this? Rainer, C, C, C is correct. We'll stop there. Good work, folks, you're doing amazing. Hopefully the quiz went well. We'll pick up here tomorrow. Remember, if you're a senior, to get your presents for your little people by Friday.